Here we go. We're recording. How's everyone doing? Maybe a thumb. Can you tell me by your thumb? All answers are okay. All thumbs are okay. Today we're going to be going through chapter 16, which is the endocrine system. Just a reminder, as you can see, we're on Zoom today. Monday, we still have another lecture. We're going to talk about part 1 of psychoactive drugs. There's 2 different PowerPoints. Sometimes I do them in the same class, and sometimes I split it up just depending on how much time we have at the end of the semester. We have some time here so that we can split it up into 2 different days. Wednesday, we'll plan on meeting in person as normal for This Is Your Brain on Drugs lab on the 18th. On the, oh my gosh, I'm losing my days now. Then Friday, the 20th, we do not have class. We do not have Zoom. So I could have had us do that psychoactive drugs part 2, but they need our classroom on the 20th. So we're going to do that on the 23rd. All right. We're going to get started. You do have a lecture assignment that is due tonight. It is from chapter 14. And I already opened chapter 16, so I didn't forget. We're going to go through the endocrine system. Okay. Feel free to unmute if you have any questions, or if you can't hear me or you can't see something, just go ahead and interrupt me, but we'll go ahead and get started. So endocrine system, here's our questions to ponder. All right, so we're going to figure out what the function of the endocrine system is. We're going to talk about what hormones are. We're going to compare and contrast steroids and peptide hormones. We're going to name the major glands of the endocrine system. We're going to talk about a couple of the disorders and treatments of the endocrine system, and we're also going to talk about diabetes. All right, so the endocrine system is comprised of glands. You've probably heard of different types of glands before, like your thyroid gland or your thymus gland, and we'll talk about those glands. But these glands essentially secrete hormones that move through the bloodstream. Okay, hormones can affect different things and they regulate different things. We've talked about hormones like in the reproductive unit. Just want to make sure everybody's in. We talked about hormones such as estrogen and testosterone. These hormones regulate pathways that can control your metabolism. So maybe you've heard of other, with age, maybe metabolism kind of suppressing or going down. How fast can you digest food and maintain energy? Growth. So as you're growing from, a young baby to a toddler to a child and so on, all of those are regulated by okay, somebody just needed me to let them in. Sorry. Just had to let somebody into the Zoom. All of these are regulated by hormones. Development, that kind of also makes sense, thinking about like puberty and how those hormones are regulated and how development is regulated. Reproduction is also by binding to the receptors on the target cells. A little bit about the endocrine system. So here's about hormones and target cells. So the way I like to think of this is like puzzle pieces. So you have these kind of pinkish, blobbish things there. Those are called target cells. And those target cells can be specific to any type or area of the body. We're just calling them target cells because of what they are here. Maybe they're in the liver, maybe they're in the lungs, maybe they're in the brain, who knows. But these are the target cells. Target just being the variable. You have kind of that orange opening here on the outside of the cell. Those are considered receptors. So if any of you are like watching football, those would be your wide receivers. They're the ones that are receiving whatever is coming out. And in this case, it's hormones. So the hormones would be like the football. All right. So once the hormones and the receiver can kind of make a pass complete here, that changes some things. Most likely it can change the shape, it can change the configuration, it can change the DNA and how protein is synthesized. Essentially, it's like when the puzzle pieces fit together, most likely something is changing or adapting, or some sort of function takes off. Here's the capillary, which we know what capillaries are from the bloodstream. So that's how the hormones are regulated. They go through the bloodstream. Hormones are chemical signals that promote communication between cells. Okay. Some things with like mental health disorders can be a chemical imbalance of that communication to the cells. It can create some sort of, I say triggered reaction, but not just saying like, oh, that's a trigger word. I mean, it triggers a reaction, so like a snowball effect of how the other cells communicate with each other. Hormones bind to those receptors in target cells to bring about their effect. So examples would be like steroid hormones or peptide hormones. Maybe the serotonin hormone. This is one that an individual with depression may be dealing with. Is that chemical imbalance? There's not enough serotonin or things like that. And I'm not a specialist by any means in that area, but what I do know about hormones is that if the chemical imbalance, so if those cells are not able to communicate to each other in that sense, it just kind of is a different reaction and things like that, or other hormones are able to bind instead of that one. So the action of steroid hormones. You've probably heard of the word steroid before. We talked about it when we talked about macromolecules, or maybe you're thinking about, oh, like steroid in professional sports or things like that, which is kind of true. But they are lipid soluble and they're derived from cholesterol. So here in this diagram, we have a steroid hormone. It's this triangle shape on the outside. It diffuses through that plasma membrane because oops, I didn't mean to hit that. Because it is lipid soluble, it's able to go through that plasmid lipid bilayer. So that steroid hormone gets through that plasma membrane. It then binds to the receptor inside the nucleus. Here's that puzzle piece here. And what happens there is it changes the synthesis, or it changes the DNA essentially, that changes the synthesis of the specific mRNA that changes the protein synthesized. All right, so we talked about how are proteins made. DNA uses things such as mRNA and tRNA, and they create RNA that creates ribosomes that create proteins. So here's our main goal, right? Proteins are the main goal. They create all the different types of functions of our body, and they also help with different traits, not only physical traits, but behavioral traits. So if that steroid hormone changes the protein synthesis, we're going to have something else that changes. So it binds to those receptors inside the nucleus. It affects the DNA activity, resulting in a protein synthesis. So now you're thinking, okay, in professional sports, why are steroids so bad? Well, we can change that protein synthesis essentially for a couple of different reasons. You can put a steroid cream, maybe you had like poison ivy or something on your leg. You can take that type of steroid cream and help fix that rash. It's not illegal or something in professional sports or the NCAA. But there's also different types of steroids. So because we're changing this protein synthesis, we can change the makeup and the buildup of, say, somebody's muscles. And that's where we get into that legal versus illegal things in different sports. The peptide hormones, these bind to receptors in the target cell plasma membrane. So the last ones, the steroids, were in the nucleus. This one is in the plasma membrane. Remember the plasma membrane, we have the phospholipid bilayer here, okay? This right here is the receptor protein. They're that wide receiver. You've got hormones that bind to that receptor. So this kind of brownish grayish thing is the hormone, the peptide hormone. It then binds to the receiver protein. And then what happens is it uses some energy and an enzyme. And what happens is the many molecules of glycogen are broken down to glucose, which enters the bloodstream. And these act as the second messenger. So here we have the first messenger, the peptide protein binds, and then we have these glucose molecules. Remember, glucose is a carbohydrate. It's like sugar. It's the backbone of sugar. So this is just another type of hormone. So the two different types I just talked about were steroid hormones and peptide hormones. What you may need to know about this is the difference in where they bind, and maybe what they create or what happens when they do bind. Right, here's a little bit more about that endocrine system. So this is kind of giving you a visual representation as well as kind of location of things and where they're at. So the first one on the top there is that hypothalamus. This is releasing and inhibiting hormones that regulate the anterior pituitary gland. Okay, this is inside of your brain, which is kind of right here. They zoom in here, that's up here. You have your pituitary gland, which is the orange part here, and this helps with water reabsorption by the kidneys, contraction and milk letdown for mammals. The anterior pituitary, it helps stimulate the adrenal cortex. It's the egg and sperm production, sex hormone production, etc. Also milk production, the growth of bone, protein synthesis, and cell division. So these are all fairly important regulated things. Here we have the parathyroids, and the parathyroids help raise the blood calcium level. Calcium's important for muscle contractions as well as the repair of bone and connective tissue. Thyroid here, you maybe heard of somebody who maybe has a thyroid disorder or had to go get their thyroids checked. This helps that metabolic rate. So metabolic rate is the metabolism. Hopefully I'm not highlighting that too much that you can't see it. I'm getting a little highlight happy here. That helps with the metabolism and how it regulates growth and development. I can think of a few examples with age, specifically females, where that thyroid gland is not working as well. And some of those, like maybe 50, 60, 70-year-old women who are, having a thyroid issue may happen to like gain extra weight or unwanted weight. That's not healthy. Obviously, everybody's different. It also can lower that blood calcium level, so the movements. So when calcium is important for muscle contraction and bone and connective tissue repair and structural things, you can see why having that thyroid not in regulation can cause some trickle-down effects. You have your adrenal gland, which is the adrenal cortex. This helps raise the blood glucose level and stimulate the breakdown of proteins. It helps with the reabsorption and the excretion of potassium. It also deals with some sex hormones, the reproductive organs, and it brings about sex characteristics. You have your adrenal medulla, which is in active emergency situations. It raises that blood glucose level. And so you're thinking, in an emergency situation, I'd have to raise my blood glucose level. That's that fight or flight kind of response. So when, there's something dangerous going on, or your body's in danger, or maybe it's just some sort of emotional trauma or things like that, that's what raises that blood glucose level in emergency situations. You have your gonads, which are responsible for the testes and the ovaries, specifically for the different sex hormones of males and females. Pancreas, this is what we're going to focus on a little bit here towards the second half of this PowerPoint. It's in charge of insulin. It lowers the blood glucose level and the formation of glycogen. This comes to effect with diabetes. Then you have the thymus, which is the production of the mature lymphocytes. So lymphocytes, remember, are part of our blood. They help fight off pathogens. They are considered white blood cells. All right, so here are the major glands again of that endocrine system. The red circled ones, the thyroid and the pancreas, are the ones that we focus on in the next couple of slides. But just know that this is kind of a list of the different glands. The ones that are circled, you may need to know some things that are more specific about those two. The first one is that thyroid gland, which I talked about a little bit. It's a large gland and it's located below the larynx. So we talked about in the digestive system, you have the larynx and the pharynx. So your thyroid is kind of in that neck region. Iodine is needed in the diet to allow the thyroid gland to produce its hormones. Thyroid hormones are what regulates metabolism, which we talked about. It lowers the blood calcium levels by stimulating the deposition of calcium in the bones. So that's a little bit about that thyroid gland that we also talked about in the previous slide. Here's a picture of that thyroid gland. You can have hypothyroidism and hyperthyroidism, the key word being the first 4 to 5 letters here at the beginning. And we'll talk about what each of those means here coming up. But here's that thyroid gland. And just to give you a little bit of kind of reference, here's that trachea or that windpipe. You have thyroid cartilage, which is considered your Adam's apple. So some males specifically have that more protruding Adam's apple. Some thyroid abnormalities. So like I said, you can have hypothyroidism. This is when there are low levels of thyroid hormones. This is characterized by lethargic. So you're really tired. I talked about a little bit about weight gain or loss of hair. You can have a cold intolerance. So you're very cold. The treatment for this is you can get a thyroid replacement hormone or called a synthyroid, excuse me. So yeah, lethargic just meaning tired, weight gain, loss of hair, or being intolerant of the cold, even though I don't have any thyroid issues, but I'm also intolerant of the cold. Hyperthyroidism, the word here, hyper, being the distinguishing factor between the last slide. This is excessive thyroid hormones. This is a Graves' disease, so an autoimmune disease. This is the enlargement of the thyroid gland. We have a protrusion of the eyes and hyperactivity and insomnia. So this is the opposite of the last slide. So last slide, lethargic just means, oh, they just are tired all the time. Insomnia meaning like they're not sleeping. I think of the like insomnia cookies. You guys like insomnia cookies? That's the way I remember what insomnia is. They're open late because when you're having insomnia and you can't sleep, you can go order some cookies. Okay, so insomnia means that they can't sleep. Here's that protruding of the eye that they're talking about, and hyperactivity. When you think of somebody who is hyper, when somebody's like, oh, I'm so hyper today, that means just they're maybe like full of energy or they're like can't focus or things like that. Hyperactivity of a hormone is essentially like those molecules that have a lot of action going on. Some of the ways to treat it are antithyroid agent called a tapazole or radioactive iodine. Remember we talked about 2 slides ago how iodine can be an important part of your diet when you are dealing with thyroid issues. All right, we've got our other gland here. So we just talked about our thyroid. The other gland we have is the pancreas. This is an organ that's located behind the stomach. This is made up of alpha and beta cells. So alpha and beta, just kind of the Greek words for 1 and 2. You know, alpha, just thinking of like the alpha, like in a lion pride or something, when you have that alpha male, or that saying, I guess, alpha male, just kind of meaning number 1, beta meaning number 2. It's just a saying. The insulin is secreted when blood glucose is high. Okay, so if somebody doesn't have diabetes, the person who doesn't have diabetes can go pretty much eat whatever they want within their own dietary restrictions. They could go have a candy bar, they could go have some chips, and most of the time the body can secrete insulin to stimulate the uptake of that glucose by the cells and use those molecules. But with somebody with diabetes, they maybe have a low insulin count or don't produce it at all. And we'll talk about that here in a second. Glucagon is secreted when the blood glucose is low. So this is like when, oh wow, my highlighter just went in the opposite direction. This is when the blood glucose is low. So it's the same thing when somebody says, oh, I have low blood sugar right now. So like maybe it's been on a really busy day and you didn't get a chance to eat lunch and it's been a couple of hours and you're kind of moody or you're kind of feeling low. That's what that glucagon is secreted into that blood glucose when it's low. And it stimulates the breakdown of glycogen so that your body can still maintain energy. This is also why different nutrients, are important in the body. So simple versus complex carbs. And that's a little bit of the difference between, when we need to use that glucagon. It stimulates that breakdown of glucogen for energy. Somebody with diabetes can't regulate these processes. So here we have the pancreas. It kind of looks kind of like a finger or something in this picture. I can't even tell you what it looks like, but this is the pancreas. We have alpha cells and beta cells. The alpha cells are good for when we need to have the cells in the liver break down the glycogen faster and release glucose in monomers enter the blood. So this is an increase in glucose because of this. When we want to decrease the amount of glucose, maybe we had a whole bunch of potato chips and some Snickers bars, and our body can still regulate when we have that much sugar or carbohydrate intake because of the beta cells. And somebody who is able to produce insulin well can then use that to kind of take up and use that glucose in the liver, the muscles, and the fat cells. These cells in the skeletal muscle and the liver store glucose in the form of glycogen. And because we store it as glycogen, when we don't have that glucose in our bloodstream, we can break down glycogen into glucose for energy. Okay. I have this slide in here, but I didn't really like it, so we're going to move on. Here's a picture of our pancreas. So you have your stomach here, and the pancreas is quite literally behind the stomach. It's right here, pancreas. All right, and here's your small intestine and your large intestine. The head would be up here of the person, the legs would be down here. Okay. It says 29.1 million people in the US have diabetes, and another 8.1 million people are undiagnosed diabetes. All right, so what is diabetes? It's the inability to control the glucose levels in the body. Again, it's a chemical makeup. It does nothing. It can be genetically passed down. It can be because of a certain lifestyle, but not always. Sometimes it's just how the body is adapting and reacting to the chemical makeup. It occurs when the body does not make insulin or its cells do not respond to it. So sometimes, most of the time, people think diabetes is when you can't produce insulin, but also the cells could not recognize it or respond to that insulin. It damages the organs throughout the body. It can cause the inability to fight off infections as well. I had a family member who had diabetes, and they had to get, the family member's no longer with us, but they had to get their legs from the knee down amputated in order to, because there was some sort of infection and their body wasn't able to fight it off. And it happens fairly more often than we think. Some of the other symptoms of diabetes is frequent urination, unusual hunger or thirst, unexplained change in weight. Now, in the couple of slides before, it said weight gain, but it can also go in the other direction too. It can be a drastic change in weight loss as well, maybe not in the healthiest way. It can lead to blurred vision, sores that heal slowly or not at all. That's kind of what I was talking about there, when there's like infections or things like that, and they're not able to heal or heal at all. Or excess fatigue, so feeling tired. Here's some other symptoms of diabetes you can kind of see here. The first one is just the different types of skin. And you can see that the bottom here, the grade 4, you've got that rough kind of crackly skin. I know this is a little graphic picture here, but on the right, then you have just some other bodily reactions to the diabetes. So they try to maintain within a certain number range of glucose. So somebody who has diabetes, it depends on the type of diabetes, and we'll talk about the two different types of diabetes, but they try to maintain their glucose in a range in order to know when they need to have insulin. There's also some, and I'm also not an expert exactly on diabetes, but there are some machines and things like that that are electronic now that can regulate insulin in the human body. I know that they can be fairly expensive. The different types, we have type 1 and type 2 diabetes. Type 1 is that it's usually early onset in the pediatric, average age of 8. And it's considered an autoimmune disorder. It's just where the pancreatic islet cells, they are attacked and destroyed, and they cannot produce insulin. This is just a chemical makeup. And as you can see, it's in the average 8-year-old that they can diagnose this. So it has nothing really to do with like lifestyle changes. It doesn't mean that this 8-year-old is by any means obese or anything or malnourished in certain ways. This is just an autoimmune disorder. It could have been genetically passed down. It could have just been how the cells were made up. And what they need to do for this is they need insulin injections. It says 1 out of 4 people over the age of 65 are diagnosed with type 2 diabetes. Now, the opposite of type 1 is that type 2 diabetes, and this tends to occur, not always, in obese and sedentary people. Sedentary means that they don't live like an active lifestyle, and an active lifestyle doesn't mean that they have to like go be an athlete by any means. It just means a lot of like couch sitting, and even though I feel like that's all we're doing these days. The target cells do not respond to insulin. They become insulin resistant, which is what I was talking about here. This is the most common type. This is the one that can correlate with lifestyle behavior changes. For the treatment of type 2 diabetes, the first is insulin if the initial A1C, which is the range, is greater than 9%. They can be injected with insulin. Metformin, it decreases that insulin resistance, so their bodies can still sometimes produce insulin, and then that metformin allows that insulin to be responded to. Exercise helps to decrease blood sugar, sometimes better than medication. And 5 to 10% of weight loss. So most of the time, if somebody goes to the doctor and they get diagnosed with diabetes, it is highly recommended to exercise and lose 5 to 10% of their weight and maintain and understand the lifestyle of healthy eating and eating things in moderation. Here are a couple of the complications of diabetes that I'll let you guys go through on your own. I feel like I don't have to read that to you. Just know that it can affect the different parts of the body in different ways. It also can be not really completely random. The random isn't the word, but it's not like you have diabetes in your skin. It just means that diabetes can affect your skin in this way. It's also not a one-size-fits-all situation. So we talked about the functions of that endocrine system, those being regulating metabolism, the sex hormones, reproductive hormones, etc. Hormones are either steroid or peptide, and just depends where they bind in the cell. We compared and contrasted the steroid and the peptide hormones. We named the major glands of the endocrine system. The two we really focused on were the pancreas and the thyroid. When somebody has hypothyroidism and hyperthyroidism, they're the opposite, and they have different treatments for that. And then we talked about type 1 and type 2 diabetes and the treatments that are needed in order to treat those diabetes. Does anybody have any questions over the PowerPoint? Okay, I have one more activity for us, and I'd like to try it out. Okay, so what we're going to do is I don't know if you guys have ever heard of Mentimeter. Maybe somebody in some other teachers have used it, maybe not. You guys are going to kind of be my guinea pigs. It's supposed to be an interactive presentation where you guys can like answer questions and then we can kind of like see the results. If you have access, I think you can either type it into your phone or your computer. So we're gonna try this one. And I think you have to go to mentimeter.com, either on your phone or on your computer, and type in that code up at the top, 7838813. And I can put that in the chat as well. Good, and then you guys should be able to answer that question. And we'll be able to start seeing the results of the question. Should people celebrate Christmas before Thanksgiving? Very nice. Give everybody a couple more seconds. We have 19 people in class, so that is 13 plus 5. All right. All right, so that was the first question. This next question, all right, it will be about the PowerPoint today. So getting those thinking brains on. I'm gonna hit the countdown. Answer fast to get more points. It's kind of like Kahoot, I guess. Oh. And I think you can check more than one. I don't know. Oh, that worked. Okay, good. Awesome. Yeah, so it regulates metabolism, growth, development, reproduction. Good. Most of you got the right idea there. All right, the next question. We've got a leaderboard there. Some of you put your names in and some of you are little creatures. That's pretty cute. All right, the next question, 2 of 5. Let's see here. Is what the action of steroid hormones. So what does it end up doing? What do steroid hormones do essentially? Yeah. So it's possible that muscles could get larger or your mood could get worse, but what they actually do is they bind receptors of the target cell in the nucleus and affect the DNA and proteins. All right, there's our leaderboard. Okay. Question 3 of 5. Oh, did it not go? I don't know why it's not going. There we go. The large gland that is located below the larynx. It's about 15 seconds to answer. Which gland is below the larynx? Nice. Yeah, good guess. So that thyroid gland, and I spelled gland wrong, I can see that from here, was below the larynx. Good job. Organ located behind the stomach. So which organ is located behind the stomach? Might be one that you have to type in. Why we get a little bit more time. Appendix, good. Abdomen, kidney, pancreas is what I was looking for. Good guessing. So a good handful that got pancreas. Okay, here's our leaderboard if you guys care. You're really competitive like me. Okay. Question 5. Number 5. I thought I had one more. There you go. How would you describe type 1 diabetes? So I think it's looking for either a word or words that describe type 1 diabetes. Very nice. That's pretty cool right there. Perfect. All right. Well, that is all I have for that one. Hopefully you guys found that somewhat fun. Maybe we can do that again. I have one more, and it has 2 questions on it. So stay with me, and it's not about the endocrine system. All right, so this one, we have a different code. And I'm pretty sure these are anonymous answers. So feel free to write what's been challenging right now. Maybe you feel like that dog. Yeah, these are good. Thanks for sharing. Hopefully by putting these up on the board, you guys can see that a lot of people are dealing with a lot of the same things right now. I'm sorry that this is all going on. My next question. Okay. So we have another lecture on November 23rd. Okay, if you can think that far ahead, I know it's so far away. So the question I'm asking is, how would you like to do this lecture? So I know that being in person is very valuable, and I understand that, but also I want to make sure that I take into account your needs, making you guys feel safe, what it means to you about that lecture on November 23rd. Because technically, still on Monday, we'll still be doing Zoom because I won't be out of quarantine yet. I will take those into consideration before we decide, but I just wanted to make sure that I heard you guys and are listening to what you guys need. Okay. Well, thanks for playing along with my little game. Hopefully you find it fun. It's kind of like Kahoots. Do you guys play Kahoots in other classes, maybe? It was kind of like Kahoots, and I had a colleague show me that, and I was like, oh, that's pretty cool. I like that it makes like little fun graphics, generates with your guys' ideas. All right. Well, that's all I have for you today. Thanks for logging on to Zoom. I will see you guys on Monday, same time, same place, for psychoactive drugs. Have a great afternoon, great weekend. At least there's some sun. Hopefully you guys can open a window and breathe some air. Walk outside if you need to. You got any questions, Sam?